Hello, quick introduction to the video. My name is Cameron. I'm a graduate apprentice software engineer currently studying at Glasgow University, and I'm using this video as a way to sort of rubber ducky debug a LeetCode problem, just attempt to solve it, talk through my thought process, and hopefully it's useful to someone watching this. So the problem I'm going to be attempting today is from the LeetCode 150 set of problems. So what I'm going to be attempting is to input array is sorted. So I'm just going to read out the spec here. Given a one-indexed array of integers numbers that is already sorted in non-decreasing order, find two numbers such that they add up to a specific target number. Let these two numbers be numbers index 1 and numbers index 2, where index 1 is less than, or index 1 is greater than or equal to 1, and index 2 is less than or equal to, or so both indexes are greater than or equal to 1, but less than or equal to the number's length. Okay. Return the indices of the two numbers added by 1, because it's a one-indexed array, as an integer array of length 2. Tests are generated so there's exactly one solution, you cannot use the same element twice, and the solution must only use constant extra space, so O of 1 space complexity. So, looking at example 1, numbers is equal to 2, 7, 11, 15, target is 9, so 2 and 7 is added. The sum of 2 and 7 is 9, therefore index 1, index 2, index 1 is 1, index 2 is 2, because this is index 1 here, this is index 2, you add them together you get 9. So, any constraints? The number's length is between 2 and 3 times 10 to the power 4. Each number is between minus 1000 and 1000. Numbers is sorted in a non-decreasing order, so in ascending order. And the target that you're looking for is between minus 1000 and 1000. So, the first thing that I'm going to do is actually have a look at two pointers. So let's have a look here. So I think this is just the use cases here. I'm going to look at, I know that this is a two-pointer problem. Okay, this didn't. Did this? You should. Okay, use in these situations. Okay, let's have a quick read through this. At its core, two-pointer techniques involves maintaining two pointers or references to elements. Okay. These are used to traverse or process data efficiently. Okay, effective two-pointer algorithms. Use two pointers to maintain left and right bounds. Move the pointers inwards. Adjust based on the sum compared to the target. Okay, so let's go into our notes using this. So I'm going to go into notes here, and we're going to say this is our numbers. So it suggested having a left and right bound. So left, we're going to say is equal to 2, right is equal to 15. So obviously it's going to be 2 and 7 is our answer, but because the target is target is equal to, or sorry, target is equal to 9. So 2 plus 15 is 17, which is obviously too big. So if it's too big, then we want to move the left bound or the right bound. I mean, that makes sense because we don't want to increase it. So we want to decrease it, so we go from 15 to 11. So we go left is still equal to 2. And the right is going to be equal to 11. It's going to be equal to 40 or 13 at this point. Still need to go down more. So we go to 7. And we've got the right answer. So I'm going to take another example and try and work through that. Okay, there's not really any other examples that I can use, but I'm just going to write down how I sort of understand this. So, have a left and right pointer. Some value at left and right pointer. Some values at left and right pointers. If it is above the target, move the right pointer, making it smaller. If it is below the target, move the right pointer, making it larger. If it is equal to target, return indices of current position of pointers. Okay. I'm just going to say repeat until target is found. So let's attempt this. I'm just going to copy and paste my notes into here and comment them out. So have a left and right pointer. So we're going to say left is equal to 0, right is equal to 0. Well, actually the left is going to be equal to 0. The right is actually going to be the length of numbers minus 1. Because this is 0 indexed, but we have to, when we return it, we have to add 1 to get it to make it appear like it's 1 indexed, I think. So just going to do a while true loop. We're going to say temp, or we're going to say if numbers left plus numbers right is equal to target, return a list with numbers, or with left plus 1 and right plus 1. Else if numbers left plus if these added together is greater than target, we're going to, sorry, I made a mess of these notes here, so I had meant to write that if it's below the target, we should move the left pointer. And these are both towards middle. Just gonna paste that back into LeetCode. Okay, if it is above, move it towards the middle, so we're going to do right plus plus, or plus equal 1, sorry. Else, and then we're just going to do this again. So if it's less than, this could just be an else, but we're just doing this to make it a bit more readable. Left minus equals 1. And then, I mean, this should hopefully work. I expected a colon somewhere. I'm not sure why. I think it needs to be elif, not else if. Yeah, I think I've... yeah. Just a syntax error. Index out of range. I'm gonna print both indexes. Sorry, the right one should move towards the middle. Should move towards the left, so minus equal 1. And this should be plus equal, that's why. These test cases pass. Gonna hit submit. And that got accepted. So now that this is passed, all that's left to do now is to go here and tick this off. Thank you very much for watching this video. I hope it was useful to you in some way, shape or form. If it was, please let me know, or if there was maybe some other way that you found to solve this that was a bit more efficient or different, please let me know. I love discussing these problems, and yeah, thank you once again for watching the video, and I hope you have a great day.